if you have an ellipse already, guys, listen to Bailey. On Friday we talked about if you have an ellipse that's already in standard form, how to find the centers, the foci, the major and minor axis, and the vertices and co-vertices. Today we're going to talk about if you have an equation, how to take that equation from general form, which means that x's and y's are just anywhere willy-nilly, and then put it into standard form so that you can find out all that information that you need to. So let's take a look at two possibilities of this. Let's start with if you're given, center and foci. So if we know what the center is and we know what the foci are, we're going to talk about how we can take that and move it into something where we can put the equation into standard form. So if you know that the center is at, let's say, 2, -3, and you know that the foci are at, say, 2 + 4 radical 2, comma 3. Oh, let's do -3. And 2 - 4 radical 2, -3. So given those two things, we're going to talk about how you can find out what the general equation of the parabola is. I might actually need to give you one more thing. So I'll give you one more thing here, and I'll tell you that the major axis is 18 units long. So I'll give you one more thing, just to make sure that we can do it. Okay, so the first thing you want to find is identify what part is what. So we've got center here, so that's awesome. That's a great way to start. So if we were looking at a general formula of an ellipse, we would have x something squared over something plus y something squared over something equal to 1. So if you know that the major axis is 18 units, you can figure out what the A is, right? So half of 18 would be 9, and that's the distance from, like if we imagine drawing this out, half of 18 would be 9, and so that's the distance from the center to an edge. What do you mean? No, what do you mean? Okay, so we know that the major axis is 9, and we know that the center is at 2, -3, so we can fill the center in first really easily. So with the x, Caitlin, I think what you were going to say is this going to be +2 or -2? -2. And if it's a +2 for the center, it's -2 in the equation, right? Well, hold on. Let's get there in just a second. And then is this going to be +3 or -3 here for y? +3. Does everybody know how I got that, the center? Or is that a mystery? Magic? All right. So if the major axis is 18 units, what is A equal to?
9 is 81.
A squared is 81, yeah. And plane A is 9. So the way that I've drawn it, you have to kind of decide if the 81 should go under X or under Y. Because you have to decide if it's horizontal or if it's vertical. Okay, why is it X, you think? Yeah, but why is it horizontal? How do you know?
A goes under its long
major axis.
Yeah. So this is going to be 81 down here.
I'm confused. Why? Oh, yeah.
So the reason that you know it's horizontal is because the foci are from the x-axis. They're up forward 2, and they're left forward 2, and they're right forward 2, which means that the major axis is horizontal, which means that your A, the bigger number, the major axis has to go under X.
Yeah, but
I'll get to that. So you look very unsatisfied with that. We'll do it more. Yep.
I'm totally confused now because I thought that it had to do with, like, you know how the long thing is like x squared minus 2x is equal
the square? We'll get to that in a second. That's our next example. Okay. No one's satisfied with what's going on right now. Okay. So let's not move on then.
That's a good way to put it.
So let's try and, like, if you imagine drawing it out, the ellipse is either horizontal or it's vertical. So forgive my potato ellipses, but so if it's horizontal, the center is right here, and the major axis is there. If it's vertical, the center is right here, and the major axis is that way.
Right, but if it's not drawn out, then how do you know?
And I'm about to show you. So the center is this point in the middle, and we don't have any information about the vertices, so we can't use the vertices or co-vertices to tell if it's vertical or horizontal. If we did, we could use those. We have information about the foci, and the foci are on the left or right-hand side of the x-coordinate.
What's the definition of foci?
The foci are those two places when I had you do that human ellipses, the two places where you put your fingers down, and then use the string and the pencil to draw so that everything was equidistant. So the foci aren't the center, they're either on the left or right hand side of the center, or they're up and down from the center, but they're on the major axis. So what we're looking at here is the foci are changing the x coordinates, not the y coordinate. So since they're changing the x coordinate, that means that they are horizontal from the center, which means that the major axis is also horizontal, which means that the larger number goes under x.
Okay.
Does that make sense for anybody else?
No.
Okay. So we know that 81 goes under x. Now, we have to use the foci and whatever a was in order to find out what b is. So the equation I gave you guys last week was that c squared is equal to a squared minus b squared. So it's kind of like the Pythagorean theorem, but not. Okay.
And what's that for?
That's in order to find out what the minor axis is, because we're still trying to find out this number that goes under here. We know what the c is, and we know what the a is.
What's
C
C?
is how much it's moving left or right from the center.
Four,
So 4 radical 2 is what c is. Monday. Okay, so this is c, and then this is a squared.
Awesome, break.
Yeah, and then you can just forget everything after spring break. That's awesome.
I forgot everything after this weekend.
Okay. So imagine what 5 days will do. So I'm going to write c squared under c squared. And since c is 4 radical 2, that's 4 radical 2 times 4 radical 2. A squared is 81. And then you need to find out what b squared is, because that's what's unknown. That's the last number you need in order to have this in standard form. Okay? So, 4 radical 2 times 4 radical 2 is going to be, yep, 16 times radical 4, which is 32. And then I'm going to subtract 81 and say that's equal to negative b squared. So 32 minus 81, like a billion, right? Negative 49, so not quite a billion. So equals to negative b squared. Ms. Angel. Okay, Ms. Angel.
Why is there 2 4 radicals?
Because I was squaring it, multiplying it by itself.
But then why didn't we square 81?
Because 81 is 9 squared, it's already written as a square.
Because 9 is 8.
Would you have preferred I wrote 9 squared instead of 81? Okay. Monday morning. Alright, so I'm just going to go one more step ahead, Caitlin, and then I'll come back and make sure everybody's with me. So, negative b squared is equal to negative 49, so that means that positive b is equal to what? Positive? Yeah.
7.
Yeah. So if b is 7, yeah, if b is 7 and b squared is supposed to go under here is 49. And now it's in standard form. I have no doubt that very few people in this room like this so far. And if somebody were to come up to me off the street and be like, "Do you ever pre-calculate?" Like, writing ellipses in standard form? And I'd say no.
No.
How
They
did
do
you
not
have
say.
to-
Why?
because
It's
I
not
thought
that
we had
hard.
to square the 81.
Sorry?
I just got confused because I thought we had to square the 81 because the A only
No, because the A is only 9. So I skipped a step. Should I not have done that?
So then what other forms are there? This is standard form.
There's general form, which I'm going to show you in just a second.
Is there everything's pretty basic? You have basic form?
Uh,
Standard, general, basic. I feel like going theme here.
No, standard is the close. If you want to think of standard as basic, that's what you should do, because that's the most usable form, because you're able
Coolest, easiest form.
standard. But so everything that we're doing is getting it into the coolest, easiest form.
Is there like a graphic?
That's the standard form. The standard form is the easiest one to graph from.
That means it all basic.
The standard form has the most utility. There are other forms. General form is what I'm going to show you next. And other than general and standard, very few are actually used. Like, you could make it all mixed up, and then it could be a mixed up form, but there's not any actual term for that. Okay, so let me go over one more example, show you your homework. Well, maybe we won't even get to homework today. But those of you who are going to be gone tomorrow will definitely get the homework anyway. But I'll show you one more example. Okay. The band, there's a district music festival. And yeah, there's track 2. Okay, so if we're taking it from general form. This is new.
So you have gotten through this and parabola? It's hard to understand this.
I have not.
So it's just, we're still on ellipses.
Yep.
So no parabolas.
No parabolas, no hyperbolas yet at all. I slowed way down.
Okay. Good. That was so
I had expected to go through everything we did and this on day 1.
Yeah.
Oh yeah,
They
no.
call
I
that
spent
turned
2
out.
hours on YouTube just like a zombie trying to observe it all.
Okay. So, okay. Completing the square. We're going to take it from general form. So general form for an ellipse would look like 4x squared plus 3y squared.
Wait, is this legit?
Yeah. Minus 8x plus 6y minus 5 equal to 0. So that's what general form looks like. You've got x's and y's lined up in descending order of power. All right? Now, the way that it's written right now, you cannot easily find out what the center is, you cannot easily find out what A or B are, and you cannot easily find out what, if it's horizontal or vertical, just based on the way it's laid out. So what you want to do is you want to take this from general form into the more usable form, which is standard. So in order to do that, first thing you want to do is get the x's and y's together. So get the variables together.
So if you're giving general form, the first step, make it standard.
Yeah, because the way it's written right now, I mean, there are people who can find out what the center and major and minor axes are based on how it looks right now, but that takes a lot of math in your head, so mathematicians are lazy, so let's make it easier. So, okay, I'm going to get the 4x squared next to the minus 8x, and I'm going to get the plus 3y squared next to the plus 6y, and then I'm going to move the minus 5 to the right-hand side. And
Is there a
then,
reason to have a big space?
yeah. Well, I guess I don't need a big space on this point, but you know, I'm going to keep that big space there for the next couple steps. Oh, yeah. We did it for circles.
Yeah, so don't
And this is the kind of, this is the problem that you were asking questions about mere moments ago. Caitlin. Yes. That you and I did together. Okay. So, in order for it to work as an ellipse, I have to get the coefficient of x squared out. And so the coefficient of x squared is 4, so I'm going to factor that out of these two terms here. So I'm going to put a 4 on the outside. 4x squared divided by 4 is just x squared. Minus 8x divided by 4 is minus 2x. Okay? And then parentheses. And then I'm going to get the 3 out of the y squared and the y. So plus 3, and then in parentheses y squared plus 2y, space, equals 5. Alright? So all I did there is I factored the two x's and the two y's individually, but on the same side. So,
Wait to take the 3 and 4 out?
nope, it's better to do it now, because now you have to complete the square, and when you complete the square, the x squared and the y squared both have to have a coefficient of 1. So you have to make it so their coefficient is 1, which means factoring out the common term between x squared and x, and y squared and y. So, next, you're going to complete the square with x and complete the square with y, like we did with the circles, but now you're going to have to do it twice, and it's a little tiny bit more complicated. So, with the x's, you start out with negative 2 here, so you're going to do negative 2 divided by 2, which is negative 1, and then negative 1 squared is 1. Because you have to complete the square with the x's. Our goal, Madison, our goal is to turn it into x plus or minus something, quantity squared. Why is there what, Bailey?
Why do we have spaces in that?
Because I'm completing the square.
He's just leaving, right?
I'm leaving space to put in a plus 1.
Because we factored the 4 out.
It's not going away.
I don't know why it's not
Carrie.
going away. Why do we put the 1 in?
Because that's the coefficient of plane x, negative 2. So if I'm going to complete the square, I have to cut that in half and then square it.
Cut in half square.
Yep. If you're completing the square, yes.
That was minus 1.
Because when what's negative 1 squared? Great.
So then you bring 2 and then square negative 1 and get 1.
Yeah. And there's a reason why. For the y's now, you're going to do positive 2 divided by 2, which is positive 1.
Squared is 1.
Squared is 1. So you're going to...
You add that to 5 and...
Nope. Okay, hold on. Before we add anything to 5. Because this is where it gets a little tiny bit trickier with this versus with circles. So, let's make sure everybody's focused. We're not all freaking out about math. Okay. So, the 1 that you added here for the x's on the left-hand side isn't really a 1.
No.
Thank you!
How is it a 4? I found that out.
Okay,
Yeah.
okay, let me explain. Or you can just freak out and not hear the explanation. That's fine. Okay, so the reason that the 1 is really a 4 is because this 4 has to redistribute eventually to everything inside. And when it redistributes to the plus 1, it'll redistribute as a plus 4. So over here on the right-hand side, I'm not going to add 1, I'm going to add 4.
And then a 3.
And then I'm also going to add 3.
So it's 12.
Yep. Okay, so now, here's where the negative 1 and the positive 1 came in. This one and this one. This is going to be x minus 1, quantity squared, plus 3 times y plus 1, quantity squared. And this is all going to be equal to 12. All right? We're almost there. But what, Bailey?
So what happens to... Oh,
You're looking for two things multiplied to be positive 1 that add to be negative 2. It would be negative 1 and negative 1. Yeah, that's... They factor out. So, now, the only thing that's different between what we have now and what the standard form in ellipse is we have to get them so that they're divided by something. So you're going to divide both everything, whole thing, by the number that's in front of x, which is 4. And then you also have to divide everything by the number in front of y, which is 3. Because you want to make it so that it is blank, like nothing in front of it, like 1, x plus or minus something quantity squared over something.
Oh yeah, so you can do pencil out and stuff.
Right, and so now, on the x's you can cancel out the 4s, on the y's you can cancel out the 3s, And then 12 divided by 4 times 3 is 12 divided by 12, which is 1. So now it's x minus 1 quantity squared over 3 plus y plus 1 quantity squared over 4. And now it's in standard form of an ellipse. So its center would be, anybody?
It's vertical.
It's vertical. The center would be 1, negative 1. Good. You could, the major axis would be 4.
How do you know?
Except what's the square root of 4?
2.
And then what's
4.
There we go.
Stop. That was confusing.
Okay. Go back. Alright, so first, the center is going to be at 1, negative 1.
Yes.
So there's center.
Yes.
The bigger number is under y, so you know it's vertical.
Okay.
The major axis is based on the bigger of these two numbers. So it's the square root of 4, which is 2, times 2, which is 4. Yeah, the a is the bigger of these two. And so this is a squared. So a is 2, and then 2a is 4.
Why would it be 8 if it's 2A?
Because this is a squared. That's not a, that's a squared.
Is it always going to be A squared? So I'm always going to have to take the square root?
And then double it.
So I should just say square root.
Okay, and then the minor axis? Is
Hold on.
Is the square root of 3?
times 2. So it's 2 root 3. Good. And then if you wanted to find out what c was, in order to find out where the foci are, you would do c squared equals a squared minus b squared,
So 4 minus 3.
which is,
1. So C is 1.
so c is 1. So the focus is 1 unit up or down from the center.
Yep. A squared minus? I don't like this.
Yeah, it's not Pythagorean theorem, it's different.
Different stuff.
Same letters.
Was it a different guy to use?
Yes.
I feel like my favorite is a lot of things.
This is Euclid.
Oh, awesome. See, I don't think I can be mathematicians. This is for school.
Is that the...
If so, I'm becoming a mathematician. Yeah,
Okay.
but then they'd be like, oh, like, it needs to be my first name. I think it needs to be my first.
Alright,
My
so
name's like an alcohol.
how many of you guys
How many of
are going to be going for?
Oh, no.
What are you going for?
Slips up there.
Well, for
Dalton, are you?
I'm gonna be gone. Yeah, you're
Captain Morgan.
Yeah, we're having
An album. About it.
Wannabe. God bless America.
Okay, so is anybody else going tomorrow? Yeah. So,
Sit next to you.
So, I'm gonna get this straight. Due next Tuesday is ellipsis and standard form, the review that I just have, and this.
yes. And then as far as that review that you don't have, hold on, let me grab it for you. Okay. So last week for